Hello, hey everyone. This is your host Saurabh. I hope you guys can hear me. Let me know if you guys are able to hear me on LinkedIn as well as on YouTube. I'm having a little bit of connection issues here on, so just be with me for a moment and we'll get started. Today's topic is very interesting, so just give me one more minute and we'll get started. Can anyone confirm me on a LinkedIn that they are able to hear me and able to see me as well? I think some of you. Okay, welcome everyone. I hope you guys can see me. Please let me know if you are able to hear me, and I hope you guys can see my screen as well. You guys can hear me live on YouTube as well as on LinkedIn. So if you are there, let me know. Oh, cool. Okay. There looks like people are joining. Thank you. I think LinkedIn is having some trouble. So let me check real quick. Okay, yeah, I think we are good now on LinkedIn as well. It's streaming live. Okay, yeah, welcome everyone. This is your host Saurabh Thawali, and most of you already know me, and you are hearing me from last 5 podcasts. So once again, welcome back to the Ministry of Automation podcast series. I'm your host Saurabh Thawali, and today we have a very exciting episode for all you test automation enthusiasts. We'll be diving into the world of cloud services and how they can supercharge your test automation efforts. Whether you are a seasoned pro automation engineer or just getting started in a field, don't worry, you are at the right place. Today, we're gonna cover everything right from scratch. What is cloud computing? What are the different cloud types? What are the different cloud service models? And what are the famous cloud services which we can consume in our test automation, and how we can leverage different services to create a full-fledged test automation framework. And then towards the end of a session, I'm going to share some of the cost-effective strategies when you are using the services on a broader scale and a large scale. You could add a lot of bill on your cloud budget. So I'll share some of my own experience and how you can save a cost on it. So just to give an introduction, who am I? My name is Saurabh. I've been in this industry for 13 years and I love my job. I love test automation. I have worked with big scale companies like Cisco, Workday, Oracle, and also worked with service companies like Cognizant, Zensa Technologies, and at present I'm working at Apple as an SDET. So let's get started. So today's agenda is we're gonna start with cloud computing. So what is cloud computing? First, I'll go over a very basic understanding about cloud computing, and then we'll see what are the power of cloud. What this new cloud infrastructure can bring to your test automation, that we're gonna see, and then we'll go a little bit of technical aspect of understanding service models. What are the different service offerings by the service providers like AWS, Google Cloud, Microsoft Azure, so we'll understand the service models, different type of clouds. So there is a service model like how you can consume cloud, what are the different types of cloud offerings, and what are the different type of cloud means, private, public, hybrids, what are the differences in them. We'll understand them, and then I'll share some real life scenarios and success stories of my own experience. I have worked with companies who operated 100% on cloud, and their test automation was also 100% on cloud. So how, when I was leading those teams, I was able to leverage the different services from these cloud providers and how I could optimize a cost when we see a huge bill on these offerings. So I'll share some of those stories under cost effectiveness, and then we'll also go over the list of AWS services. So as you know, what is cloud computing? So cloud computing on a very simple way to explain is, you don't have a computer, let's assume, and you want some computing power, which means you want to run a game or you want to do some calculations or anything which need processing, and you don't have computer. And let's say you only have mobile right now, and you want to do something on an internet. The same computing you can do over an internet, and who is doing the processing? Someone else who has or who owns a computer is doing on your behalf. So basically cloud computing is, you are consuming a computing power from someone else, rather than you yourself maintaining those servers or those computers in the background. Someone else is doing it on your behalf, and you are just consuming the output. So cloud computing, majority, on a broad level, you can categorize into two things, like server hosted on a cloud, or maybe some kind of a uh, computing capability in the cloud. So cloud computing basically refers to the delivery of various computing services that can include server, storage, database, networks, different softwares, analytics, everything which can run over the internet, which is referring as cloud. So this allows organization and individual to access and use these resources on pay as you go basis, which offers flexibility, scalability, cost effectiveness to them. They don't need to worry about buying a big hardwares or costly machines, or a place where they can put those machines, the cooling system, so that the machine can operate in a right temperature. And if machine goes down, a maintenance team who can repair them and bring it up back. They don't need to worry about all that. They can only use them over the cloud, over the internet, and just pay for whatever purpose they have used it. So cloud computing eliminates the need for organization to invest in and maintain their own physical IT infrastructure. So that's a very basic about what is cloud computing. There are a bunch of different cloud services. So don't worry about that. We're going to go over some of them in very high level, specifically related to test automation. Now let's talk about power of cloud in test automation. So let's go to 10 years back. I started my career in 2009. That time there was a minimal use of cloud services in test automation. Most of the test automation was on-prem, like on our physical devices, or on physical machine. We used to write a Selenium WebDriver script, run it on our own machines, and whatever the test results, it's going to keep our machines engaged. And then we started putting it on the VMs. If you listen my previous podcast, which is infrastructure as a service for a test automation engineer, there have talked about the evolution of how the test automation has evolved 10 years back till today. We used to do it on-prem, then VMs, then started doing it on containers, then using Kubernetes. So I have talked about all these different stages of evolution in test automation. So nowadays, if you talk about power of cloud computing, cloud services offer several advantages for test automation engineers, making it easier to set up, scale, manage test environments. Some of the cloud services which can be used is, let's say, for scalability. Cloud services provide on-demand access to resources, allowing you to scale your test automation infrastructure up or down as per the need. This is specifically needed running large-scale test automation test suites, where handling of spike in testing demand without the need of significant upfront investments in hardware. Another good advantage or a power of cloud computing, it could be the cost efficiency. With cloud services, because you pay for what you use, this can significantly reduce the cost of maintaining and operating those physical test environments. If you remember 10 years back, we in every office who used to provide some testing services to their clients, they'll have dedicated servers, machines, and if the testing needs doing a testing on different OS types or different kind of devices, different browsers, we need to create that environment on our own machines. I have a Windows machine, have a iOS machine, then the different type of browsers you need to download, different devices, if it's Android, if it's iOS, if it's iPadOS. So there used to be an investment, upfront investment, to have all this infrastructure so that we can run our test automation on them. So nowadays we don't need to worry about it. The another good advantage for this is global availability. Now the cloud providers are available around the world, so you no need to worry about the application's performance testing from this point in the globe. You can calculate the latency, user experience in the different regions by using these services. You no need to worry about all this putting your upfront infrastructure cost to test these kind of things. You can do parallel testing because of cloud services now. It allows you to run parallel across multiple virtual machines at the same times, or containers. So what I'm trying to say here is, if you consume the cloud services in your test automation framework, you could save not just money, but you can enhance or expand the scope of your automation. You can do testing in isolation, you can do continuous integration over the cloud, you can do on demand environment provisioning, diverse testing environments. You can set it up, as I said, they are available globally. You can do automation scaling. We're gonna see all that in our next segment, where I'll talk about what are the different service offerings we have. So yes, the power of cloud automation is immense and it's growing, and it's just a matter of time that almost 80% of things which we currently do manually in test automation, probably move it on the cloud, and all the services are available. It's just a matter of using and consuming them in our infrastructure. I'm going to share some of the realistic stories you guys can connect. So those who haven't used their services in their test automation, and they want to start just with one service. Let's say I haven't used any services, Saurabh, in my test automation framework. How can I start with one service and see whether it's useful, or uh, I can collect analytics from that and then enhance it for some more services. I'm going to share that example with you guys, so stay with me. Let's talk about cloud service models. On a broad level, there are three service models, in which you can get the service offerings from cloud providers: infrastructure as a service, platform as a service, and software as a service. So what is infrastructure as a service? So as I said, infrastructure as service is basically you are getting all the infrastructure needed for your computing, for your execution. Like, you don't need to buy those costly Windows machines or Mac OS, or kind of servers or hardware devices like mobile devices, Android, or different versions of Android, or different versions of um iOS or iPad or watchOS or so on. You don't need to worry about all that. If you need servers to put your Jenkins, or install Jenkins and do something else, you don't need to actually buy all that in for your test automation. So you can just provision some of the machines over the cloud, and then you can consume them. That is comes under infrastructure as a service. So there are different service providers, like AWS is the famous one, Google is there, Microsoft is there, and there are a lot of other uh, companies also who provide hybrid and private cloud. We'll talk about it in our next segment. But yes, there are different and multiple providers who can provide you this, basically rent you those infrastructure and say that, hey, if you use for 2 hours, just pay me for 2 hours, and that's it. Like you rent a car, right? You don't invest in the car in every city you travel. You just rent a car, use it, and whatever days you are using the car, you just pay for it. Similar to that, just assume or imagine that the infrastructure, whatever the compute power, the storage power, the networking, the security, the different kind of proxy messaging, load balancing, whatever you may need, you can just rent that, use it, pay for whatever, and then just uh, move ahead. Platform as a service. So what is a platform as a service? So platform, just think in this way. uh, when I moved to United States, I didn't see the woodwork here and there when the building construction was going on for people. What I mean to say is, if I want to do woodwork on my own, I have to invest in all those costly machineries which can help me cut the wood, polish the wood, or maybe transport the wood from place A to place B, right? uh, if I go to some kind of a shop, let's say Home Depot or any lumber mart, where they provide me everything, I just need to do the thing which I like with the wood, create my furniture, and just pay for the use whatever I am consuming at that place. Consider that as a platform as a service. So you don't need to buy all the devices and tools and everything which you might need to create that furniture, right? You just go to the place who can provide all that things to you, which is basically a platform as a service. You go there, you use all these different machineries, the tools, and sometimes they even offer their expertise, uh, and then create your furniture there and then come back with a polished furniture at home. So similarly, you can think of this way. There are a lot of startups who are coming and who want to create different type of applications, but they don't want to invest upfront in all the infrastructure needed or all the different tools needed to create their applications. So they go to the platform as a service kind of a providers. So those platform of as a service providers will provide all the different things which they might need to develop application, and you just pay for whatever platform you are consuming. And software as a service is pretty straightforward. There are a lot of enterprise softwares which are delivered on cloud. Salesforce is there. Workday, which I worked, is delivered on the cloud. You file your taxes, TurboTax, over the cloud, over the internet. That is all software as a service. You are getting all the complete service software over the internet. If you remember 15 years back, you used to buy the CD or kind of a hard drive. We used to have executables and then install it on your own system, then only you can consume that software, right? But right now you no need to do that. You are not installing anything, not even a plugin nowadays. You just access a complete software, a big enterprise software, just over the internet, and that's a software as a service offering. So these are the three major service models. There are some more to it, like you can get a containerized, serverless and all. We'll not talk about it here, but yes, that's the something which you want to uh, understand. What types of cloud? What are the types of cloud? Public, private, and hybrid. So public cloud is basically, it's it's a shared resources, which means, let's assume I have a one big server whose capacity is, let's say, 10 terabytes, and I want to rent that one server to n number of people, and those n number of people are ready to share that one server for their needs, because they are okay to pay less. Their data is not sensitive, and they have very limited and temporary usage. So basically, public cloud is something which is shared. Uh, the storage can be shared, the computing devices can be shared, the networking or all the different offerings by the service provider would be shared across users. That's a public cloud. The private cloud is, obviously, as name indicates, it's secure. It's only dedicated to the organization or a person who is buying or renting that particular resource. When I say resource, it could be anything. It could be a computing power, storage capacity, networking, or any other offering by the cloud services. So private cloud is only confined and limited and restricted to the particular organization or a particular person, and that underlying infrastructure wouldn't be shared with other people. It's dedicated to that particular person, and it's of course comes with a cost, because if you have 10 terabytes and it's on a private cloud, the organization might be using just 1 terabyte, and they are still paying for the complete 10 TB, because that is on hosted on the private cloud. So that 9 terabyte which is not used, it can't be rent or can't be leveraged to some other people, because it's not allowed. So that's a private cloud. Hybrid cloud, as name indicates, a combination of public and private cloud, and it can be on-prem as well. There are different offerings nowadays. If you go to HP GreenLake and a lot of other companies who provide this kind of an offerings, where you have a cloud infrastructure, but it can be a private hosted on your prem. Okay, so which means you don't need to pay for all the infrastructure, but you also want that infrastructure to be located in your premise. So you are kind of a client who are worried about that, hey, I'm using cloud services but I don't know where those servers are located. What about if I'm using it in United States and if their servers are somewhere else in the geography where my government may not permit me to transmit a data or anything like that, or that's the reason I want to use a cloud services but I not want to make sure that underlying infrastructure is privately located. So that's kind of a mix of a hybrid cloud comes into play, and there are such companies who say that, okay, you only pay for infrastructure you consume and we're going to place that infrastructure on your prem at our cost. So it's a very interesting thing which is getting evolving in a cloud computing, but that's kind of a hybrid cloud you might see. Now let's talk more about live scenarios. So before I jump into the live scenarios, let me talk about different AWS services, because this is what I believe most of you joined the session, that hey Saurabh, I want to know what are those services can be used in my test automation. Let's talk about the famous AWS services which are used very regularly in test automation, starting with Elastic Compute EC2. So what is Elastic Compute EC2 service? In a simple word, it's a compute service, which means it's a machine, some kind of a machine you're renting. You need to provision that machine. So what is provisioning? I'll talk about it, but right now what you need to understand is you are basically not buying a computer to run your test automation. You are not even using some kind of a remote machine or a VM, basically at your own cost. Like, you are not buying it, you are just uh, creating that instance, creating that machine which your test environment needs, and then you're running your test automation in that, and then you killing that instance. So basically, just to give an example, let's say you need a Windows machine, and you want to run your test automation, browser test automation, let's say UI or anything, and then after your test automation is done, you want to just leave that machine. So in an ideal world, you would say to your manager that, hey, give me one strong remote server where I can set up my test environment, run my test automation, so that we don't need to rely on my own laptop or my own machine all the time when I'm running test automation. Uh, your management may say, yes, okay, let's buy a remote machine, or let's have a remote server. But if you understand what was your test execution needs are, and if you create a similar EC2 machine on the cloud, by creating EC2 machine means you have to define what type of OS you want, what type of networking you want, what type of storage you want. There are a bunch of things which you generally need to be aware when you are provisioning a particular machine, because provisioning machine is basically a list of steps which you need to define in order to have that instance ready. So you can have on different OS, different storages, different networks, different security, all those things, and it's not straight, it's not difficult. You can automate that as well using infrastructure as a service softwares like Ansible and so on. So you can automate that provisioning as well. So when you run your automation on those kind of cloud instances, once your automation is done, you can just stop that instance or kill that instance, and you just only pay for how many hours of test automation is been executed on that EC2 instance, and what type of EC2 instance it is. Based on that, you're gonna pay to that service provider like AWS. Now coming back to AWS Lambda. Now this is a serverless execution. So what is serverless execution? I'll give you a simple example. So let's say in your test automation you have some function to execute. Let's say adding two numbers, right? You not necessarily need a complete machine to do that kind of a function execution. In a 10 years back or 15 years back, you would say, yeah, of course I need a machine, so because I'm running a code, right? How that code would get executed or compiled without a machine? The answer would be okay. 15 years back, 10 years back, it's okay. But now today, you don't even need an EC2 instance. Ideally, you don't need to pay for that EC2 instance as well, just to run that function. If you want your execution to be serverless, which means machineless. Of course, it will execute on the machine, but you are not renting, you're not provisioning that machine for your test automation. You are consuming AWS Lambda service, which is serverless execution, and you're running your test automation on that. So it is one of the cost optimization strategies where we spend a lot of money on just EC2 instances to run a test automation, and we revisit on a test automation, refactor a complete framework so that some of those parts can be consumed by or can be run on Lambda, AWS Lambda, so that we save a cost on EC2. So I'm going to talk about it on the next segment, how to create a cost effective cloud testing framework. There we'll cover it, but that's another offering. So this is an interesting thing. So AWS will only charge for the amount of execution you have done. You're not consuming a complete machine for it. Just to give a high level example, let's say your test automation need is very bare minimum, but you are still spinning up a machine, which means you are provisioning a complete EC2 hardware. You are defining how much of storage you might need. You are defining all kind of security policy, networking, and everything. The machine is taking, let's say, some minutes to get started. Then you are running test automation for some time, and then you are killing it, or you are just hibernating it. Here your test automation may not even need the entire storage which is used to create that machine. So let's say you are creating a machine for 1 gig, or let's say of 1 TB. You may not even need that 1 TB, but you are still paying for it. So rather than that, you can leverage and use AWS Lambda and save there. So your test automation can run on it. Another very famous service offering which is nowadays used in our frameworks is S3, which is simple storage service. Basically it's a storage service offering by the Amazon, and this is also one of my favorite service because we can do a bunch of things in our test automation using this service. What else we can do? For example, some test automation are data intensive. You run test automation, you create data files which are huge, or you take screenshots, you do recordings of your execution, you generate a lot of resources like XML files or kind of a log files. And if you end up storing them on EC2 itself, basically on a same machine, whatever the storage you have mounted, if you are consuming a same storage, you are basically slowing down those machines. So the good thing is use the S3 storage buckets. So have a S3 storage bucket where you can park all this execution data, which means logs, screenshots, recording, data files, or whatever your execution is generating. You can put them on these S3 storage buckets, and once your execution is done, and if everything looks good, you can probably get rid of those data as well. Again, this is another topic. I'm going to talk about cost effectiveness, because S3 is an interesting service. It has a different storage classes. You can leverage a different storage class based on your execution strategies, and there also you can save. You can change the storage classes as well. The standard S3 to glacier to deep glacier, and archive, and all those things. So once you do that, you can significantly bring down your S3 cost as well. So that's that's the topic for talking about the next segment. Relational database service. So like now you guys can understand everything which we're doing it manually or on our own machines. Now it's everything can be consumed over the cloud by our test automation, right? So similarly, the database service is one of the database service. There is SQL, NoSQL, all those kind of services are there. The famous is the RDS service we can use. The code pipeline service is there, CloudWatch service, device forms. So there are a bunch of service. I'm not going to talk about all that in detail, but I hope you guys are getting a high level understanding about how we can use these services in our test automation, and get rid of that infrastructure cost, or maybe try to optimize what we can consume in from these services. Device farms, for example, you can enhance the scope of your test automation to the different devices available from the device farms. There are a bunch of different variety of iOS devices you might want to test on. There are different Android versions, there are different browsers, there are different hardwares, different Linux flavors, OS versions, browser types. So all these things can be consumed on a device farm. You don't need to worry about buying all this or installing on your own on your own test environments. Of course, you have to set it up. There are some more services which you can well, if you want, you can leverage them, which is, IAM service, identity and access management service. Specifically, when you're doing a security testing, you want to make sure that your test automation is been outsourced to someone else and they are having right access. You can use or integrate that in your framework. um, this is another, if you talk about EC2 service, this is ECS. It's a elastic container service. So where you only spin up containers, what and in that containers you run your test execution on. Inspector service, step functions, secret managers. So there are some more advanced strategies which you may want to put it on your automation roadmap. But yes, these are some of the more services. Now let's talk about an interesting thing, uh, which is live scenarios, right? I was talking about how we can leverage these services or reduce the bill, which is our next interesting segment. I'm going to finish it. We are already over time, but let's say compute bill, which is EC2. You are consuming some kind of a machine over the cloud to run your test automation, and I have worked in an environment where we used to run 1600 to 1700 scripts in one day, in just morning regressions. The health check scripts, regression scripts, and a lot of bunch of things. So our automation used to run 3 to 4 hours every early morning in my previous companies. Uh, and everything was to run on EC2 instances, and it was a huge bill because as we grow automation, we're gonna add more and more automation to our inventory. The cost of that underlying infrastructure where our test automation run is gonna increase every quarter, every year. And of course, AWS is also gonna change their costing tiers, or and they're gonna increase the price year on year, of course, due to inflation. So basically, you are anticipating to pay more and more every year because you're adding more automation, as well as the service provider who is charging you is going to increase the underlying cost for your compute or storage or anything. So these were the main two costs for my company previously, wherever I worked. Let's say how we optimized it. So some of the strategies I would like to share here is with you. So let's say if your compute bill is a lot, like you are having a bunch of EC2 instances, everyone will start with bare minimum understanding of how they can leverage these services for test automation. But eventually, when you start seeing this cost going up, you want to implement these optimization strategies. So there is a way how you can automate your EC2 instances. There is a spot called as spot instances. There are reserve instances and on-demand instances. So on-demand instances are basically you are defining what kind of EC2 instance you want and you are provisioning it. Like I said, there are provisioning and automation tools like Ansible, where you basically define the steps and that kind of a machine gets created for you. The spot instances and reserve instances are kind of a readily available by the AWS, and they are kind of a lesser in cost compared to on-demand instances. So in some of the test automation you can use them, like for example a high level health check scripts, or the scripts which are not data intensive or which can run anytime in your day, right? You can try using some of those. Use hibernation. So one of the thing I have noticed in test automation who consumes EC2 is once the test automation is done, they're gonna keep that instance alive for, let's say, till next day. Or some people I have even seen that they just spin one EC2 machine and then they use for years together, because or let's say months together, because every day they run the automation and then that's it. They don't even kill that machine. They say, hey, you don't want to kill, you can just hibernate it. That will help you to save a cost, and next day before your test automation begins, you can resume it, you can start it back. Clean up unused resources. That's the best thing you can do. Once your test automation is done, and if the test automation is 100% green, which is 100% passed, uh, the 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 general tendency is no one goes back and look at the green test results. So the best is to kill those EC2 instances or stop them, as well as whatever the data they have consumed in those S3 storage buckets, you can also purge them, get rid of them, or move them to another storage class like Glacier, Deep Archive, where you can store for some days and then have a policy so that you can get rid of them. So that is one of the strategies to save on this kind of a cost. Turn off the instances, like I said. Storage bill. There are a bunch of things I can talk about storage bill because I have personally worked on all this cost optimizations. Is using right storage class is important. For example, uh, S3, as you know, has a different storage class, and you pay based on what storage class are you using. So very standard, or the first time user will end up using S3 standard buckets, which is basically the costly. If you store a lot of test automation data in it, like screenshots, recording, logs, data files, XMLs, and all the resources which gets generated during your test automation, if you store on those kind of a storage classes, and if you don't get rid of them, or if you don't change their storage classes, you don't replicate their data to another cheaper regions, you will end up paying a lot in just storage cost. The right strategy would be, once your test automation is done, if it's 100% successful, the probability is no one is gonna look at it. If you want still a data to be there on the, like, if your client needs it, or if you want to maintain it as stuff for some kind of historical auditing reason, move it to another storage class, which is, let's say, Glacier, or Deep Archive, where you still have a data but you may not have readily available. Like, once you click on generate log, it will take some time, 5-10 minutes, and then you will have the logs generated. You still have it, but you save a cost on it, the storage cost. Enable compression. If you are doing a recording of your execution and you want to maintain that recording of your execution, if you are doing some image processing, you are doing some data intensive stuff, have a compression logic automated so that you compress those, and store it in some kind of a different object in an S3, so that the size gets decreased and you are charged for less. But when you are consuming it, you decompress it back to the version you want. So basically you are consuming the mix of compute and storage to save on this cost. Implement data lifecycle policies. Like I said, one of the strategies which we have used in the past is replicating data to the cheaper regions. So let's say if I'm running in United States and my S3 storage is here, it's gonna cost me differently than if I replicate the data and move it to a deep storage in some other region where the cost is significantly low. I'm making sure that my data is still there if I need it, but I'm storing it somewhere else. So that kind of strategy also can help you. Tag your S3 buckets, because if you run analytics over the period of time, you see what kind of storage is being used for what type of S3 objects. You can have a very good analysis and create optimization strategies from that. So that's a high level thing which I would like to share with you guys in this session. Now let's talk about the EC2 cost, which is basically another big cost. Which here, consider using spot instances. I have already covered. Use serverless options, AWS Lambda. Wherever you don't need a complete machine or complete instance to execute, and you can automate those workflows by running it on AWS Lambda, why not use a serverless option? It will cost significantly less than having a complete EC2 instance. Use auto scaling features, so you no need to worry about spinning the n number of machines and only 50% of them are being consumed. If you write auto scaling features, use then the way your test automation workflow has been designed, it will auto scale it, and it will provision only the required instances, required machines. Sizing your instances rightly, that is very important. Sometimes I have seen that we write only one infrastructure as code script, which is pretty standard across the test automation projects. Like, this is the standard EC2 machine which you're gonna create for test automation. Sometimes that may not be a right strategy for you if you are cost, you are worried about your costs. So make sure the type of automation you are running, what type of instances that particular automation needs, and depending on that you have to size your machines rightly. Scheduling to scale your instances, scale down, all that. You can use it early morning. You can run your health check scripts, or run at the time where the cost is less in a region where it's less, that kind of thing. Optimization I already talked about. Use of free services tiering, for your education purposes, knowledge transfer trainings and all that. There are a bunch of AWS free tier services are available. Use and leverage them. Monitor and set alarms. If your daily usage is above a particular threshold, have an email sent to your stakeholders so that you all are together brainstorming on how you can bring that particular cost or consumption down. Read and publish your automation service consumption cost. This is one of the health strategies, like automation health index strategies, which you can implement, where you are consistently looking for the amount you are spending on the services, and then talking and brainstorming on optimization techniques. Device farms, I already talked about it. So yeah, I think this is what I would like to share it with you guys for today, about how and what or different type of cloud services you can leverage in a test automation. Of course, I am also learning a lot of things. It's not like I have learned everything and used everything, but it was very interesting when I started working with this cloud services in my test automation, uh, in some of my previous projects. And I have realized that I have only 10 or 20% of a knowledge even today, because there is a ocean of information out there. I only try to understand which is relevant for automation engineering, because there is a bunch of AWS knowledge is available around you, but not everything might be relevant for a test automation perspective. So that's the reason this was my small effort, to share what the test automation could be used, and we can leverage for. So thanks everyone for joining this session. I hope you have enjoyed this session, and if anything has added a value, like in today's session, so please let me know. You can comment on a LinkedIn, or on a YouTube. So yeah, that's a wrap for today's episode on cloud services for test automation engineers. I hope you have gained some valuable insights into how the cloud can take your test automation game to a next level. And remember, it's a journey, and the cloud is your trust companion. So thanks for tuning in, and I'll catch you in the next episode of Minister of Automation. Stay curious and keep automating. Thank you. Bye bye.